In today's video, we're going to discuss least common multiple. This is going to look very similar to what we did yesterday with GCF, and some of it is similar, but there are different pieces to it that you need to pay attention to. So let's first talk about the vocabulary. Least common multiple. Well, least is the smallest. Common is one that appears on both or all lists. And multiple, think the word multiply, which means all of our numbers are going to be bigger. We're going to create these lists that get bigger and bigger and bigger. Today, there's actually 3 methods that I'm going to show you. 2, I think, are a little bit easier to use, the list and the ladder. I think tree, while you're very comfortable with it, and we talked about it yesterday, I think that might cause you a little bit more headache than you need. All right, but we'll do it anyway. So we're going to find the least common multiple of 14 and 21. I'm going to start with the list because I think it's the easiest. So for the list, you literally make a list of all the multiples. Now, when you've got numbers like 14 and 21, they're going to get really big really fast. So in this case, you might want a calculator to help you through, or you're just going to have to do some little calculations over on the side. So for 14, 14 times 1, 14 times 2, 14 times 3, you can see I'm doing my calculations over here on the side. 14 times 3, 14 times 4, 14 times 5, and you would keep going on and on and on. This is a 0. You would keep going on and on and on. I don't know where I need to stop, so for right now, for my sanity's sake, I'm going to stop here. I can always go back and add more to my list afterwards if I need to. All right, so 21 times 1, 21 times 2, 21 times 3, 21 times 4, and then 21 times 5. And again, I can go back and add more later if I need to. So I have a list of multiples, and I would like to find the least common, the smallest one that happens on both lists. So let's go through until we see one. Oh, here we go. Here's 42. That is the first number that appears on both lists. So my LCM is 42. Now, pretty straightforward, but the numbers can get kind of big kind of quick. And imagine if you had a third number, if you were trying to find the LCM of 3 numbers, that could take a while. Let's go look at 2 other methods that you might like a little bit better. I'm going to do the tree. The trees get done the same way that we did them for GCF. You split them until you get to only prime numbers. So 14 is 2 times 7. And 21 is 3 times 7. Now this is where things get confusing. In the other method for GCF, you wanted the stuff that duplicated. But for LCM, you want to include everything but not the duplicates. So I need to include a 2, I need to include a 3. Because these duplicate, I'm only going to include one of them. I don't really need to count something twice, that's just extra, we don't need that. So my LCM is going to be 2 times 3 times 7, or 6 times 7, which is 42. Same answer we got with the list. That's good. The reason I don't like this is because it confuses kids often with what do I include and what don't I include, and when do I do the duplicates and when don't I do the duplicates. I think the trees are a little easier for GCF. I think they're a little harder for LCM. But if it makes sense to you, use it. It's perfectly acceptable. Now, let's go to the ladder. And I got feedback from some of you yesterday that you didn't quite like it because you'd never seen it before. I think today might convince you to like ladder, especially if you have to do both GCF and LCM for the same numbers, which happens a lot on worksheets and tests. This will do both of them with no extra work. It's amazing. All right, so let's go. 14 and 21 side by side with that little stair step thing. I don't even know what to call it. We need a number that will divide into both 14 and 21. 7. 14 divided by 7 is 2. 21 divided by 7 is 3. Is there anything left in common between 2 and 3? No, just a 1, which we're not going to do because it doesn't change anything for me. We would just get a 1 and 2 and 3 again. Do you remember that vocab word? When there's nothing in common except for a 1? It's 2 words. Relatively prime. The 2 and the 3 are relatively prime. The only thing left in common is a 1. Now, for GCF, we multiply the stuff on the side. For LCM, it makes a big L. Everything on the outside gets multiplied. And there's my 7 times 2 times 3. 6 times 7 is 42. Super fast, super organized, and it did it for you. Now, if you had to find the GCF for this, it would just be 7. You don't have to do anything else. You just have to know where to look. All right, let's try a set that has 3 numbers. So we're going to find the LCM of 4, 5, and 10. Now remember that the ladder method will not work for more than 2. So the ladder, unfortunately, is not an option for this case. We're down to list or tree. I'll do both to show you. Luckily, these numbers are a little smaller, so your lists will go a little faster. So let's do 4 times 1 times 2 times 3 times 4 times 5 times, let's try that again, times 5 times 6 times 7 times 8, and I could continue on if I needed to. All right, let's count by 5s. 5 times 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. Oh my goodness, that's a 4. And I could continue on if I needed to. All right, count by 10s. Times 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. And I could add more if I needed to. So I'm looking for the smallest number that happens on all 3 lists. Let's see. There's a 10 and a 10. There's a 20 and a 20 and a 20. That's it. That's the smallest number that happens on all 3 lists. The 10 and the 10 didn't do it because we didn't have a 10 on the other number. Now, are there other multiples that happen on all 3 lists afterwards? Absolutely. 40 would be another one. 80 would be another one. 100 would be another one. But we're looking for the least. All right, let's see what this looks like on the tree. So 4 gets split into 2 and 2. 5 would be split into, 5 and 1 because it's already prime. And 10 would be split into 2 and 5. So I've got 2 times 2, 5 times 1, and 2 times 5. Now remember, we don't want any duplicates. So I've got a 2 here and another 2 here. Because that number had 2 2s, this should be a 5. Because that number had, nope, scratch that, I'm going to rewrite it. 2 times 2, 5, and 2 times 5. Starting over. This 2 and this 2, because remember we have to count everything, and this 5. I already have a 2 included, so I'm not going to count this one. And I already have a 5 included, so I'm not going to count this one. Now, why did I count these 2? Because they were from the same number. Okay, we wouldn't want to duplicate this way between numbers. We want to do it this way. That's why I don't like this tree, because everyone's like, well, why those 2 but not these 2? And why not the 5? Go with the list or go with the ladder. In any case, this becomes 2 times 2 times 5, which is 4 times 5, which is 20. The same answer we got from the list. If I had to make a recommendation, I'd say forget the tree for LCM. Although the book will show you, lots of teachers show it. I even showed it to you here. I would stick with the list or the ladder. Now, if you're comfortable at this point, you can go on and do the practice. If you want to do one more with me, I will happily do one more to show you how we do this. I'm going to go back and do a 2 number one. So we're going to do the least common multiple, of 24 and 60. All right. Now, these numbers are crazy big if you're doing the lists. Let's see. 24, 48 times 3 is 72 times 4 is 96. Oh my goodness, I got to keep going here. 24 times 5 is 120. Add another 144. I'm going to stop there for right now. If I have to add more, I can later. Let's go to 60. 60, 120, 180. Let's see if I got anything. There it is. Now, that wasn't terrible, but it was kind of a pain to have to do 24 times tables. So let's look at this with the ladder. Put your numbers next to each other. Draw your first step. What's a number that goes into both 24 and 60? You might be thinking a bigger number. You might be thinking a simple 2. That's where I'm going to start. I always like to show these stepped out because you don't have to think of some crazy big number. If they're both even, 2 will work. All right, so 24 divided by 2 is 12. 60 divided by 2 is 30. Is there anything in common between 12 and 30? Yeah, they're both even. So let's do another 2. 12 divided by 2 is 6. 30 divided by 2 is 15. Anything in common? They're not both even, but they do both have a 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. Anything in common between 2 and 5? Nope, they're relatively prime. Now, if you remember, GCF was on the side, but LCM makes the L. So I'm going to multiply 2 times 2 times 3 times 2 times 5. That's a lot of multiplying. Well, this we know is 10. This is 4. This now is 12. So my answer is 120. Hey, it's the same I got before. I love the ladder for this because it's easy.